Good morning, student. In this video, we are going to discuss the next chapter, graph theory. We are going to discuss the next chapter, graph theory. When we are studying mathematical ideas, we defined about graph. What is the meaning of a graph? We said graph is a collection of vertices and edges. Graph is the collection of vertices and edges. In singular, we call it as vertex, and this is edge. This is what we defined in the mathematical ideas. We defined about the graph, and we discuss some problems. And we draw some graphs using vertices and edges. Now, here we are going to define the degree of a vertex. We are going to define the degree of a vertex. The meaning of degree of a vertex is nothing but the number of edges passing through the vertex. Number of edges passing through the vertex. This is called degree of a vertex. See, for example, we are having a diagram. We are having 5 vertices: 1, V1, V2, V3, V4, V5. We are having 5 vertices, and we are having E1, E2, E3, E4, E5, E6, E7, E8, E9, E10, and E11. Here we are having loop V1 and V3, E3 and E11. We are having a loop. For the degree of a vertex, in general, loop constitute 2 to the degree. Loop constitutes 2 to the degree. This is the basic idea. Now, for this diagram, I am going to find the number of vertices. We are going to find the edges, and then we are going to find the degree of vertex. Then we are going to find the degree of vertex. So now, how we can represent this graph? The graph representation is G. I am having 5 vertices and 11 edges, isn't it? We are having 5 vertices with 11 edges. So this is the representation of the graph. Now I am going to find the degree of each vertex. I am going to find the degree of V1, degree of V2, degree of V3, degree of V4, and degree of V5. We are going to find the degree of each vertex. The meaning of the degree is nothing but how many edges are passing through the vertex. When I take V1, how many edges are there? This is 1. E2 is 2. E4, E3, E5. Isn't it? Here E3 is a loop. E3 is a loop. So I am going to count the number of edges. 1, 2, 3, 4, 5, 6. Because loop constitutes 2 to the degree. So E1, 1, 2, 3, 4, and 5, 6. So the degree will be 6 because we are having E1, E2, E3, E4, E5, where E3 is a loop. Where E3 is a loop. In the same idea, we are going to find the degrees of other vertices. We are going to find the degrees of other vertices. What about V2? We are having 1, 2, 3, 4, isn't it? We are having 4 edges passing through V2. So I am going to count. E4 is there, E6, E7, E8. When we are checking for V3, I am going to check how many edges. This is E8, E10, E11, but E11 is a loop again. So I am having E8, E10, E11, where E11 is a loop. That means 1, 2, 2 plus 2, 4. Isn't it? 2 plus 2, 4. Next I am going to check for degree of V4. How many edges are passing through? 1, 2, 3, 4 and 5. Isn't it? There is no loop here. We are having 5 edges. What are all the edges we are having for V4? For our convenience I am writing it. This is E10 is there. We are having E7. We are having E6. We are having E5. We are having E9. 1, 2, 3, 4, 5. Now the degree of V5, I am going to find the degree of the last one. What is V5? Here I am having how many? 1, 2, 3. What are them? This is E9, E2, E1. So to find the degree of a vertex, I am going to check how many lines or how many edges are passing through the vertex. Here we can check. I am going to find the sum. I am going to find the total. How much is this? 6 plus 4, 10. Plus 4, 14. Plus 8, 22. Here the total degree of the graph, VG, all sum. I am going to find the sum of the graph. This is 22. Sum of the degrees of the vertices is 22. This you can check or you can verify easily. Always this should be 2 times of the edges. It should be always the 2 times of the edges. What are the edges here? How many edges we are having? 11 edges. So the total number of the degrees, the total number of the degrees of the vertices, it should be 2 multiply the number of edges. The 2 multiply the number of edges. This formula is called hand shaking theorem. This is called hand shaking theorem. So to find the degrees, we are going to count the number of edges passing through them. And then I am going to find the total of the number of the degrees, and then I am going to check whether I am having 2 times of the number of edges or not. We are going to check whether we are having 2 times the number of edges or not. This is called the introduction to graph theory. Here we are going to discuss 2 more ideas. One is called adjacent vertex and another one is called adjacent edges. See here, we are going to discuss about adjacent vertices and adjacent edges. The meaning of adjacent vertices is nothing but the vertices connected by an edge. Connected by an edge. See, for example, I am going to check the adjacent vertices of, let me take V1 for example. The meaning of adjacent vertices, V1 is connected to which vertices? Through a edge. When I take V1, V1 is connected to V2. So V2 is an adjacent vertex. V1 is not connected to V3. That means V1, V3 are not adjacent vertex. When we take V1, V4, yes, it is connected by a edge. So V1, V4. V1, V5, yes, they are the adjacent vertices. So the meaning of adjacent vertices are nothing but we are going to take the vertex or we are going to take the vertices that are connected by an edge. In the opposite, when we are discussing about the adjacent edges, where the edges that intersect at a vertex. For example, I am going to check the adjacent. I am going to check the adjacent edges. The meaning of adjacent edges, for example, I am going to take E1. E1 is adjacent to, what are all the things I can say? E1 is adjacent to E2 because it is meeting with E2 in one point. E1 is adjacent to E3 because it is meeting with the one point. E1 and E4, yes, they are having a common intersection vertex. E1 and E5, yes, they are intersecting at one point. E1, E6, no, they are at the different vertices. The next one I am having only for E9. E1 and E9, they are intersecting at one vertex. So the meaning of adjacent edges, I am going to take the edge and I am going to compare the other edges where they are intersecting at one vertex. Now using this idea, in the next video we are going to discuss about how we can represent the graph. A representation of graph we are going to discuss in the next video.